Hello, so welcome muli dito sa Static of Rigid Bodies natin. So, ang topic naman natin is moment of force about specified axis. Dun sa naunang topic natin about dun sa cross product, nakuha natin is the resultant moment. Kaya lang, ang problema dun is yung nakukuha nating resultant moment is nakadepende doon sa kung ano yung magiging result ng ating cross product. In actual practice kasi, may mga pagkakataon talaga na ang kailangan nating moment ay yung naandun sa specified axis. For example, itong figure na to. Makikita natin dito sa figure na to. Halimbawa, itong tire wrench na to ay gusto nating i-design yung kanyang strength so that it can carry the stresses that can be produced during yung time na tatanggalin natin yung bolt. So, most probably, itong member na ito yung i-consider natin doon sa ating design. And mai-consider lang natin ito doon sa ating design kung mayroon tayong data regarding the moment or torque na nag-a-act dito sa member na to. So, kung gagamitan natin ito ng cross product, halimbawa, kinuha natin gamit yung cross product, most probably yung ating resultant moment ay mag-a-act dito sa part na to. And ito yung kanyang magiging axis of rotation. So, hindi reasonable na itong moment na to ang gamitin mo para i-design yung member na ito. So, para ma-design mo itong member na ito, kailangan mong i-determine yung moment ng force na yon parallel dito sa line na ito, sa y-axis. In that case, ang kailangan mo moment is the moment my, yung moment my natin. And kung kukunin natin yung moment natin dyan, yung moment about y-axis or the my natin is equals to the force times the perpendicular distance. So sa case na to, ang perpendicular distance natin is the dy. So kung susukatin natin mula dun sa force na yon, mayroon tayo dito perpendicular, and yung perpendicular natin is dy. And halimbawa naman, kung gusto nating kunin yung moment ng force na to along x-axis. So ang mangyayari sa atin, ito yung ating force, ito yung magiging perpendicular distance natin. So dito sa dito sa figure na to, masyadong simplified, mas madaling ma-analyze. Pero pag minsan yung situation ay mas mahirap compare dito sa figure na to. So doon pumapasok yung method natin about Cartesian vector formulation. So kung titingnan natin yan, kung babalikan natin yung mga topic natin, alam natin na to determine the moment of force, ginagamit natin yung cross product. So that's why meron tayo ritong R cross F. So yung R natin dito is the position vector from point O going to the given force. So meron tayong R cross F para ma-determine natin yung moment of force. But yung topic natin ngayon is to the specified axis. Dapat yung moment natin is about the specified axis. So halimbawa, kung yung ating kukunin is about y or moment about y, kung babalikan natin yung dot product natin, so using that product, pwede nating makuha yung force along specified line. Ngayon, sa moment din, pwede rin natin gamitin pala itong dot product para ma-determine yung moment along dun sa given line. Kasi alam naman natin na yung nakukuha nating moment using cross product is a vector. So this one is a vector. So kapag minultiply pala natin siya using yung dot product doon sa unit vector along the line kung saan natin dinidetermine yung moment, kung saan natin kinukuha yung moment, pwede rin pala natin makuha yung moment along that line. Kasi yung application ng ating dot product is to determine the component of vector at a given line. So kung babalikan natin yung figure natin, halimbawa ito yung ating given vector A, and this is our component. So let's say this is the line AA. So using that product, pwede natin makuha yung component nitong vector na ito. Itong vector na to. So ganun din sa moment. Ang nangyari lang, yung vector A natin, instead na yung vector A is in force, yung vector A natin is in the form of moment. Pero tatandaan natin na yung force natin is in the form of vector, yung moment natin is in the form of vector pa rin. That's why pag kinunan natin to ng component along line A, itong vector A natin, which is in our case ngayon ay moment, pag kinunan natin yung component yun yung equivalent moment niya doon sa line na yon. That's why possible pala sabihin natin na yung moment along y is equals to the unit vector j, dahil yung ating line of yung line na kukunan natin ng moment is along y, and we know that the unit vector along y is j, that yung moment at point O, which is the r cross f. So pwede pala natin gamitin yan. So pwede rin na yung ating moment na kukunin ay hindi nakaparallel doon sa ating mga x and y axis. So halimbawa, determine the moment along this line, along this line. So ang gagawin natin, kukunin lang natin yung unit vector nitong line na to, kung hindi siya nakaparallel sa any axis. So baguhin siguro natin para mas maganda. Halimbawa, dito siya ayan, let's say dito, para mas maganda. Ayan. So ang gagawin natin para makuha natin yung moment of force produced by F along this axis, kukunin natin yung unit vector nito. Let's say this is unit vector P. Sabihin na natin, this is moment, this is line B, line OB. So kukunin lang natin yung unit vector nito. I-multiply natin doon sa R cross F ng ating given force. So magiging formula natin is M along line B multiplied by the unit vector at P dot yung ating cross product para sa R and F. So yung R natin is any position vector from point O going to the force F. So pwedeng yung position vector mo na yan, pwedeng ganyan. Kaya lang sa case natin na to, kasi mas madaling ma-determine yung ating position vector kapag dito natin nilagay. So kung mababalikan ninyo yung principle of transmissibility, pwede natin gamitin yon. Halimbawa, nandito mas convenient. Let's say yung position vector na R1 ay mas convenient. So pwede natin sabihin na yung MB is also equal to unit vector at B, that yung ating R1 cross F. So yung principle of transmissibility. Okay, so ito yung mas magandang illustration para dun sa moment natin along given line. Let's say yung required na kunan natin ng moment is yung line A. This is line AA, yung line na to. Dito natin kukunin yung moment na na-produce ng ating force. So hindi na about point O. So about line A na yung kukunan natin ng moment. So tatandaan natin yung ating moment about given line. Let's say line A is equals to unit vector at A. Siyempre, this is in Cartesian vector form, that yung ating R cross F. So in our case, ito yung ating R, and then yung ating F ay ito. So makikita natin kung expand natin yung unit vector A. So alam naman natin na unit vector A is the component of that unit vector along AX, along Y, along Z, multiplied by the unit vector natin na IJK. So expand lang natin siya doon sa component niya. That product natin siya doon sa determinant ng matrix ng ating R cross F. So yung R cross F natin, kung susulat natin yung kanilang mga components, so ganito yung magiging itsura niya para pag ginamitan natin ng determinants, mas madali nating masosolve. So pwedeng ganito yung maging result niyan. Pero ako, halimbawa ako, mas may advice ko na ang isaulo na lang ninyo is itong nasa ibabaw, kasi mas madaling isaulo ito, kasi alam niyo na yung unit vector ng isang given line is simply the component of that line along X, Y, Z, and then multiply mo lang sa IJK. So madaling tandaan yon kasi ginagamit natin yon lagi-lagi mula dun sa mga nauna nating topic. And then alam naman natin na yung R cross F is simply the determinant of a matrix ng ating R and ng ating F. So pwedeng ito yung tandaan na lang ninyo kaysa isaulo ninyo ito. Okay? So gamit yan, makukuha natin yung moment parallel dun sa line A. And isang importanteng formula din na dapat tandaan is yung unit vector. Yung unit vector natin in Cartesian vector form ay pwede rin nating express yan gamit yung ating moment along A, in Cartesian vector form divided by the moment along A in scalar form. That's why nagkaroon tayo ng ganitong formula. So tatandaan pa rin natin yan, and pwede rin nating tandaan yung moment along A, or the moment of force along A in scalar form is also equal to kung ano man yung let's say hindi siya naka-parallel doon sa line A, doon sa XYZ axis. So siyempre magkakaroon siya ng component along XYZ. So pwede natin sabihin yung square root ng lahat ng component niya along XYZ, and then i-square natin. AX, M, AY, and then M, AZ. So plus, and then square. So pwede rin gamitin itong formula na to. Okay, so yan yung mga kailangan nating tandaang formula para dun sa moment of force about specified axis. Okay, so example tayo rito. Sabi dito, determine the moment AB, at line AB, produced by the force in the figure which tend to rotate the rod about the axis AB. So dito siya magro-rotate. So paano natin kukunin yung moment natin dyan? So ang una natin gagawin is establish natin yung ating formula, which is yung moment about line. Let's say sa atin ngayon, if line AB is equals to the unit vector ng ating line AB, that yung ating cross product ng ating position vector pupunta doon sa ating force. So yung ating position vector, di pa natin alam kung alin yung gagamitin natin, pero po pwede natin gamitin itong position vector na to, or pwede rin na itong position vector na ito. So syempre, kung ito yung R1 natin, and this is our R2, kung ako ang papipiliin, mas pipiliin ko yung R2 ay yung R1, kasi unang-una, isang axis lang yung consider natin doon sa ating position vector. So kapag mas kakonti yung given, mas madaling i-analyze yung ating problem. Okay, so kung isusulat natin yung position vector natin in Cartesian vector form, so R1 in Cartesian vector form, that is equals to, so mula doon sa A, travel siya papunta doon sa intersection ng ating force. So ang distance pala nun is 0.6, so meron tayong positive 0.6 I. And then pag nakuha natin yung position vector natin na yan, i-transform natin yung force natin from scalar papunta sa Cartesian vector form. So madali naman na natin metatransform ito kahit din na natin gamitan ng force directed along the line. Kasi yung ating force is directed na along doon sa ating k-axis. So mayroon tayong, dahil siya ay downward, against siya doon sa ating right hand rule, so mayroon tayong negative 300 k. So from that, pwede na natin i-perform yung ating R cross F. So yung R cross F natin, susulat lang natin lahat ng ating mga component, let's say I, J, K, and then sulat natin yung mga component natin para sa R. So mayroon tayong 0.6, and then 0, 0. And then we have, para sa F, mayroon tayong 0, 0, and then negative 300. So tatakpan natin yung ating I. So meron tayong 0 times negative 300. So ibig sabihin, yung result ng ating R cross F, R1 cross F is equals to, so yung una, tatakpan natin to. So meron tayong 0 times negative 300, that is equals to 0, minus 0 times 0, that is equals to 0. And this is our I. And then we have minus, tatakpan natin yung J natin. So meron tayong 0.6 times negative 300, 0.6 times negative 300. Yeah. So palitan siguro natin to ng bracket. Okay. So minus 0 times 0, that is equals to 0. So this is our J, and then dun sa ating K, pag tinakpan natin yan, ang makuha pa rin nating result is 0. So 0K. So yung R cross F natin is equals to, so meron lang tayong 300 times 0.6. So negative yun, may negative dun sa labas, so magiging positive. So positive, ilan yan? 0.6. So 0.6 times 300 is positive 180. So yung ating direction is along J. Okay, so dahil meron na tayong R cross F, so kailangan na lang natin kunin yung unit vector along AB. So para makuha natin yung unit vector along AB, kunin natin yung position vector along AB. So yung position vector natin along AB is equals to, so magta-travel tayo mula doon sa A. Travel tayo mula sa A ng 0.4, 0.4i. Then magta-travel tayo papunta doon sa Y ng 0.2j. So sa K tayo, wala na tayong travel, kaya 0 na siya. So ito yung ating RAB in Cartesian vector form. So yung RAB natin in scalar form, kailangan din natin makuha para doon sa ating unit vector para sa position vector na yan. So mayroon tayong 0.4 square plus 0.2 square. And then square root niyan is meron tayong 0.4472. So kung kukunin natin yung unit vector ng ating AB, Cartesian vector form, so meron tayong 0.4 over 0.447. So that is 0.4 over 0.4472i plus 0.2 all over 0.4472j. Okay, so yung unit vector at AB natin in Cartesian vector form is equal to, so 0.4 over 0.4472. So meron tayong 0.89 0.45 I plus 0.2 over 0.4472 is also equal to 0.4472 J. Okay, so meron na tayong unit vector at AB, meron na tayong cross product dun sa ating R1F. So, pwede na natin gamitin itong formula natin para sa moment na equals unit vector AB dot cross F. And tatandaan natin yung formula natin nung nakaraan para sa dot product is equals to AX, BX, and plus AY, BY, plus AZ, BZ. So, gamit yung formula na yan, so, makukuha natin yung moment along AB, that is equals to, so yung AX natin, which is yung, in our case, yung A natin is yung R cross F, So, yung AX natin is 0 dahil 180J lang yung nakuha natin doon, so 0. And then, yung BX natin is 0.8945, plus AY natin is 180. And then yung BY natin is 0.4472. And then plus yung ating AZ is 0 and yung ating VZ is also 0. That's why yung sagot natin dito is 0. So makukuha pala natin na yung moment natin automatic, this is in scalar kasi dot product yung gagamitin natin. So makukuha pala natin na yung moment natin is equals to 180 times 0.4472. So that is equals to moment about along the line AB is equals to 80.496. So ang unit natin is Newton meter. Okay? So kung dadalhin natin ito in Cartesian vector form, madali na lang kasi yung ating formula kanina para sa moment, moment at AB in Cartesian vector form. Moment AB, AB in Cartesian vector form is simply the scalar, scalar ng ating AB, moment AB, multiplied by the unit vector along AB, multiplied by the unit vector along AB. So, i-multiply lang natin yung 80.496 dun sa ating unit vector AB. So, makukuha na natin yung ating moment in Cartesian vector form along AB. So, moment natin. So, kung multiply natin yung 0.8945 times 80.496, that is 72, almost equal to 72i plus yung 0.4472 multiplied by 80.496, that is 35.99 or 35.9978 J. So ang unit natin is equals to Newton meter. So ito yung ating Cartesian vector form, ito yung ating scalar form. Okay, so example number 2 tayo. Sabi rito is determine the magnitude of the moment of force F about segment OA of the pipe in the figure. So ang kailangan nating kunan ng moment is yung ating pipe. So ano yung ma-develop na torque dito sa pipe OA. So para makuha natin yan, gagamitin ulit natin yung formula natin kanina. Yung ating moment about OA is equals to yung ating unit vector along OA dot yung ating cross product ng ating position vector and yung ating given force. So establish ulit natin yung ating position vector na R. So paano natin kukunin yun? So pwedeng gamitin natin position vector mula rito papunta doon. Okay, let's say this is our RBC. Yan. Okay, so yung RBC natin, kung titignan natin yan, magta-travel tayo doon sa ating x-axis. So mula sa x-axis natin, yan. So magta-travel tayo ng 0.1. At 0.1 doon. So meron tayong 0.1 I. And then plus, ta-travel tayo mula doon ng 0.4. 0.4. Yan. So meron tayong 0.4 J and then ta-travel tayo pataas ng 0.3 plus 0.3 K. Okay, so yan yung RBC natin, and yung ating force na 300 Newton, dapat i-convert natin siya into force directed along the line or in Cartesian vector form. So para ma-convert natin yan, kunin muna natin yung position vector ng ating line CD. So line CD. So ang direction natin is from C going to D. So para makarating tayo doon, travel tayo rito ng along x-axis. So yung ita-travel natin is kung 0.5 yun, so meron tayo ritong 0.1, nabawasan ng 0.1, so malamang ito ay 0.4. So meron tayo 0.4i, and then pupunta tayo doon sa against doon sa ating y-axis. So ang distance niyan is 0.4, negative 0.4, kasi siya ay against doon sa ating positive. So meron tayong 0.4 J, and then aangat tayo. So kung ito nakaangat na siya ng 0.3, so yung natitira na lang doon sa 0.5 is 0.2, so plus 0.2 K. So pag nakuha natin yung RCD in Cartesian vector form, so kunin din natin yung ating RCD in scalar form. So yung scalar form niyan is 0.4 squared plus negative 0.4 square, and then plus 0.2 square, that is equals to 0.6. And then kung kukunin natin yung unit vector natin para sa CD, unit vector CD in Cartesian vector form, so divide lang natin yung 0.6 doon sa ating mga component. So meron tayong 2/3 I para dito, so 4 divided by 0.6, and then minus 4 divided by 0.6 is also 2/3 J, and then 2 divided by 0.6 is 1/3 K. So pag nakuha natin yung ating unit vector along CD, so i-multiply lang natin yung ating scalar para siya ay maging force directed along the line sa ating CD. So yung ating force is in scalar is 300, so multiply lang natin dito sa unit vector natin. So 300 times 2 is 200. 300 times 2 divided by 3, so 300 times 2 is 600 divided by 3, that is equals to 200i. Then this is also 200j, kasi same silang 2/3, plus 300 times 3 divided by 3, so that is 100k. Okay, so ito na yung ating FCD in force directed along the line natin, along doon sa ating para sa ating force na 300 Newton. Ngayon pag nakuha na natin yan, pwede na natin gamitin yung R cross F. Kasi meron na tayong position vector BC. So may position vector BC na tayo, and meron na tayong F. So kung isusulat natin yan, kukunin natin yung cross product niyan, susulat lang natin yung mga component niya. So meron tayong component ng ating R, so 0.1, and then 0.4, and then 0.3, and then yung force natin is 200, and then negative 200, then positive 100. Okay, so kunin natin yung determinant of matrix natin. So meron tayong ito, kung tatakpan natin yung x, so meron tayong 0.4 times 4.4 times 100, so meron tayong, so this is our BC cross FCD is equals to, so meron tayong 0.4 times 100, that is equals to 40, 40 minus 0.3 times 200, that is equals to negative 60, kasi negative 200, negative 60. Yan. Okay. So lagyan natin ang I, and then minus meron, tatakpan natin yung ating J, J. So pag tinakpan natin yung J natin, so meron tayong 0.1 times 100, so that is 10, minus yung ating 0.3 times 200, that is ilan yan, 0.3 times 200, that is 60. 60. Yan. So meron tayong J, and then plus yung sa K natin. Pag tinakpan natin yung K natin, meron tayong 0.1 times 200, so that is negative 20, kasi meron siyang negative sign, and then minus 0.4 times 200, that is equals to 80. Yan. So meron tayong K. So yung R cross F natin, or RPC cross FCD, is equals to 100i plus 50j minus 100k. So, mayroon tayong R cross F. So, ang kailangan na lang natin is the unit vector ng ating OA. So, yung unit vector ng OA natin, kailangan muna natin isulat yung ating position vector OA. So, position vector OA natin is equals to, so yung O to A natin, para makuha natin yung position vector natin dyan. So, meron tayong travel tayo rito ng yung distance na yan. So, yan ay 0.3. So, meron tayong 0.3i. And then, travel tayo mula doon, papunta doon. So, meron tayong plus 0.4j. And then, dahil naandun na tayo sa A, wala na tayong travel along A. So, yung ROA natin, kailangan kunin natin yung scalar form nito. So, meron tayong 0.3 plus 0.4, square natin, then square root natin yan. Para makuha natin yung scalar form yan. So, that is equals to 0.5. So, yung unit vector natin along OA, unit vector along OA, in scalar ay Cartesian vector form is equals to, so divide lang natin itong 0.5 doon sa 0.3. So 0.3 divide 0.5 is 0. Yan, 0.3 divide 0.5. So meron tayong 0.6, 0.6i. And then 0.4 divided by 0.5 is 0.8j. 0.4 over 0.5. Meron tayong 0.8j. So, mayroon tayong unit vector along OA. So, gagamitan na lang natin siya ng dot product. So, yung dot product natin, AX, BX, A dot B is equals to AX, BX plus AY, BY plus AZ, BZ. Yan. BZ. Okay, so yung dot product natin or yung moment na natin along OA is simply the 0.6 times yung ating 100. 0.6 times 100 plus yung ating J is 0.8 times yung ating 50. 0.8 times 50J. Okay, so yung moment natin is equals to 0.6 times 100 plus 0.8 times 50. So, makukuha natin is 100. And, syempre, yung magiging unit natin, dahil yung mga dimension natin is in meter, tapos yung force natin is in Newton. So, Newton meter. Okay, so ito yung scalar form niyan. Kung gusto natin kunin yung Cartesian vector niyan, multiply lang natin itong scalar na to dito sa unit vector OA. So, pag naka-Cartesian vector kasi, pwede nating malaman kung paano yung rotation ng ating moment. Kasi pag ipinlat natin yung makukuha nating position, makukuha nating vector using yung ating unit vector OA saka yung ating moment OA in scalar form, pag ipinlat natin yan, lalagay natin yung hinlalaki natin doon. So kung ano yung magiging UP ng ating apat na daliri, yun yung magiging rotation ng ating moment. So kung maalala nyo yung topic natin regarding sa cross product. Okay, so try naman natin i-solve ito. May mga pagkakataon kasi na may mga ganitong problem na pwede tayong ma-encounter regarding sa moment. So, sabi dyan, a jib crane shown in the figure is subjected to three coplanar forces. Replace this loading by an equivalent resultant force and specify where the resultant's line of action intersects the line, the column AB and boom BC. So, kailangan natin i-locate daw yung ating resultant force, yung line of action niya, kung saan siya nag-a-act dito sa ating system. So, may clue na tayo dyan. Most probably yung ating yung line of action ng ating resultant force daw is nag-a-act or naka-cross doon sa ating AB and doon sa ating BC. So maaari pag ganito yung direction ng ating resultant force. But before that, kailangan muna nating makuha yung summation ng forces along X and summation of forces along Y para makuha natin yung resultant force. So summation of forces along X natin is equals to meron tayong let's say yung going to the right, yung i-assume natin as positive. So meron tayong negative 175. And then we have another negative para sa component ng ating 250 force. So meron tayong negative 3 over 5 times 250. And that is equals to 175 minus 3 over 5 times 250, that is 325. Negative 325. So, pinapakita lang nito na yung direction ng ating resultant force para sa X, or yung summation ng force natin along X. Ang direction niya is is going to the left kasi negative yung sign niya. So pag ginawa natin siya ng free body diagram, make sure na yung direction ng ating resultant force or ng ating force along X, yung summation ng force along X ay going to the left kasi yung sign natin is negative. Okay, so summation of forces along Y naman tayo. So meron tayong let's say upward yung ating positive, no? So meron tayong downward na negative 60 pound, and then we have another downward component ng ating 250 pound. So meron tayong 4 over 5 times 250. So meron tayong negative 260. So kung isusulat natin yung parallelogram ng ating resultant force, so maaring ganito yung itsura niya. So meron tayong negative Fx na 325 and negative Fy na 260. So pag inilagay na natin yung direction niya, tanggalin na natin yung ating sign na negative, ano? Kasi ibig sabihin pag nilagay na natin yung direction, na-i-express na natin yung negative sign. Okay? So kung ganyan yung ating force, yung free body diagram, malamang ito yung ating force polygon or yung ating parallelogram. So nandito yung ating resultant force, and malamang yung direction yan din yung magiging direction ng ating resultant force dito, ano? Okay, so yung resultant force na yan pwede nating ilagay at any point dito sa line na to, ano? So itong line na to is siyempre nakaparallel yan dito sa ating dito sa resultant ng ating parallelogram, ano? So at any point of this line, ano, pwede nating ilagay yung ating resultant force, ano? O pwede nating ilagay in the form of this resultant force or sa form na siya ay naka-extract into component, ano. Okay, so para mas madali nating ma-solve siguro, palagay ko pwede nating ilagay ito gamit yung ating mga components. So meron tayong 325 and then we have 260, ano. So dito ko siya ilalagay para mas madali natin siyang ma-solve, ano. Okay, kasi pag diyan natin nilagay, ano, so yung magiging problema lang natin is the y-axis, ano, kapag dito tayo nagkaroon ng summation of moment, ano. Halimbawa, mag-summation of moment tayo sa A. Summation of moment at A is equals to, ano. So considering yung ating resultant force muna, ano. So meron tayong 325 actually ito. So meron tayong 325. Let's say yung ating assumption is going to yung ating assumption is clockwise as positive. So meron tayong negative 325 times yung ating perpendicular distance is yung y, ano, y. Okay? So yan yung para sa resultant force, ano. So that is also equal dun sa moment na na-produce ng ating original forces, which is yung 175, yung 60, and yung 250 natin, ano. So pag isosolve natin yan, so kunyari wala ulit yung ating resultant force, kung isosolve natin yan, so meron tayong summation of moment at A taking clockwise as positive pa rin. So meron tayong negative 175 multiplied by yung ating moment arm na 5 feet, 5 feet, and then we have clockwise, ano. So meron tayong plus 60 times yung ating moment arm, so magkakaroon tayo 90 degrees doon, so 3, and then yung ating y component para doon sa force na yon, that is equals to 4. So yung direction niya is clockwise, so plus, ano, so plus 4 over 5 multiplied by 250, times yung ating magiging moment arm. So mula rito sa point A hanggang doon sa tapat nun. So magkakaroon tayo doon ng 90 degrees. So that is 3 plus 5. So times 8. Okay, and then yung component naman niya along X. So mayroon tayong counterclockwise. Mayroon tayong minus. And yung component natin is 3 over 5 times 250 times yung ating moment arm mula rito sa A. So magkakaroon tayo ng perpendicular distance doon. Okay, so yung distance natin is 6 plus 5, that is equals to 11. So alam natin na ito ay equal sa summation of moment at A, and itong alam natin na ito is equal sa summation of moment at A, and this one is also summation of moment at A, So ito ay summation of moment at A. So pwede nating i-equate tong dalawang equation na to. So pwede pala natin sabihin, siguro kunin na natin yung result muna nito bago natin equate para mas maiksi na lang yung isusulat natin. So this is negative 745. Oops. 745. Okay. So i-equate natin ito dito sa equation natin na to. So meron tayong negative 325 y equals to negative 745. So kung i-divide natin both side by negative 325, so makukuha natin yung value ng y, which is equals to 5 by 325. So mayroon tayong y is equals to 2.292 feet. Okay? So kung mayroon tayong 2.292 feet mula rito, papunta doon sa line of action ng ating resultant force. Yan, 2.292. And ito, ipoproject natin papunta ron. Yan yung magiging line of action ng ating resultant force. Okay. Yan. So, kung mayroon tayong 2.292 dyan, so, makakagawa tayo rito ng triangle. So, mayroon tayong makakreate dito na triangle. So siguro kukunin muna natin itong angle nito, itong theta nito. So makukuha natin 'yan gamit dito. So sigurado equals lang 'yan. Yung angle na 'yan kasi dito 'yan ang galing. So using yung ating tangent theta is equals to the opposite. Ang opposite natin is 260 over the adjacent natin is 325. So yung theta natin dito is magiging inverse tangent ng ating 260 over 325. Yan. So yung theta natin ay magiging 38.66 degree. Yan. Okay. So ngayon po pwede na nating i-segregate itong triangle natin na to dito sa drawing natin para hindi na masyadong magulo. So siguro dito ko na lang siya ilalagay. Yan. So yan yung magiging triangle natin. And then ito, alam natin na yung distance nito is 2.292. So yung total nito, alam din natin yan. So from this drawing, so meron tayong 5 plus 6, so that is equals to 11. So malamang itong distance nito mula doon hanggang doon, that is 11 minus 2.292. Okay? So, itong distance na to, yan yung isa pang kailangan kasi natin. Kasi kailangan daw natin i-locate. So, let's say that is x kasi hindi pa natin alam. And malamang yung x na yan, ito rin yan. So, kailangan tayo ritong x. Yan. So, pag nakuha natin yung x, sabihin na i-locate na natin lahat yung location ng ating line of action dun sa ating force system. So, of course, this one is theta. Okay, so paano natin makukuha yung x na yan? So, computein natin yung 11 minus 2.292. So, mayroon tayong 8.708. 8.708. Okay, so using tangent, makukuha natin yung ating x. Meron tayong tangent theta is equals to, opposite natin is 8.708. 708 all over the adjacent natin is x. And we know that theta is equals to 38.66. So makukuha natin yung x which is equals to natin ang boundary. So yung x natin is equals to 8.708 divide by the tangent 38.66. Okay, so makikita natin na yung x natin is equals to 10.88. So okay, so ibig sabihin this one is 10.88. Okay, so yan yung magiging location ng ating line of action ng ating resultant force. Okay, so another problem tayo, no? So dito, pag ganito yung situation natin, ganito yung problem natin, ang gagamitin natin is yung tinatawag natin na Varignon theorem. So yung Varignon theorem is kukunin natin yung total magnitude or the resultant ng ating mga forces. Multiply natin yan dun sa distance niya from reference. And that is equals to the summation of all forces multiplied by the x or the distance from the reference ng ating individual forces. Ano? Okay, so para mas maintindihan natin to, tignan natin dito sa example. Ano? So bago natin i-solve yan, assignment natin, the slab in the figure is subjected to the 4 parallel forces. Determine the magnitude and the direction of the resultant force equivalent to the given force system and locate its point of application on the slab. So kailangan nating ma-locate kung saan mag-a-act yung ating resultant force. So ibig sabihin, dapat meron tayong value ng x dito at meron tayong value ng y. Ano? Okay? So, bago natin magawa yan, kailangan muna natin kunin yung resultant force. So, para makuha natin yung resultant force, isum lang natin lahat ng forces. So, obviously, yung mga forces natin dito is vertical lahat. So, summation of forces vertical, taking upward as positive. Okay, so makikita natin, ang upward lang naman dyan is yung 100 Newton. So, siya lang yung positive. And then we have 600. And then we have negative 500. And another negative 400. So, makikita natin yung force vertical natin is equal to. So, mayroon tayong 100 minus 600 minus 500 minus 400. Okay, so meron tayong negative 1,400. Negative 1,400. Okay, so verify lang natin. Negative 600, negative 500, negative 400, negative 100. So, negative 1,400. So, ano yung ibig sabihin ng negative? So, ibig sabihin yan, dahil na-assume natin upward is positive, the direction of the resultant force or yung summation ng ating forces is downward kasi yung sign natin is negative. Okay? So, ibig sabihin this is downward. Or let's say dito nag-a-act yung ating resultant force, yung ating FB, yung summation of forces vertical at B, which is 1,400. Okay, so tatanggalin na natin yung negative kasi isinet na natin yung direction niya na downward. Kasi yung sign natin, yan lang yung magsasabi kung ano yung direction natin. Okay? So, kung yan yung ating resultant force or yung summation of forces along vertical axis. So, magkakaroon tayo rito ng distance. So, let's say this is x. And of course, kakaroon din tayo rito ng another distance. Let's say this is y. Yan. Okay? So, yung x and y na yan yung tutulong sa atin para ma-locate natin yung position ng ating resultant force. So, gamit yung Varignon theorem, sabi dyan, the resultant force times yung kung ano yung distance niya from the reference. So, kailangan natin mag-set ng reference para ma-determine yung location niya along x. Siyempre, set ko tong axis na to as my reference. Okay? So, dito ako magpe-perform ng moment. Ibig sabihin, ito yung magiging axis of rotation ko. Okay? So, setting this line as axis of rotation. And dito magkakaroon ng moment. So, magkakaroon tayo ng yung ating Rx, which is 1,400. Yung ating R, o resultant force, which is 1,400. And i-multiply natin kung gaano siya kalayo mula sa reference line natin. So, in this case, ang reference line natin ay ito. So, gaano kalayo yung ating force from the reference. So, ang layo niyan, or perpendicular distance niyan is x. So, that's why, ay lalagay natin dito x. And that is equals to the summation of forces times yung x ng bawat forces. So, nandito tayo sa line na to. So, mayroon tayong 600. 600. So, gaano siya kalayo doon sa ating axis of rotation. So, nandun siya sa mismong axis of rotation natin. So, ibig sabihin yung distance, perpendicular distance natin is 0. So, the same with yung ating 500. So, meron tayong 500. So, yung distance din niya is 0 din dahil nandun siya sa mismong axis of rotation na isinet natin. And then, we have yung 100. So, let's say, ito yung ating assumption. So, siya ay against the rotation. So, meron tayong negative 100 times. So, yung magiging distance natin is 5 meter. So, meron tayong 5. And then, yung other force natin is 400. So, kung titignan natin, aayon siya sa rotation natin. So, meron tayong 400 times yung magiging distance natin is 5 plus 5. So, meron tayong 10. So, makuha natin yung value ng x. Okay? So, yung value ng x natin is negative 100 times 5 plus 400 times 10. Okay? So, 1,400 divided by answer. Paano ba? So, divide by 1,400. So, meron tayong x is equals to 2.5 meter. Okay? Para doon naman sa y, i-set naman natin to as axis of rotation. So, dito tayo magkakaroon ng axis of rotation ng ating moment. So, ang mangyayari dyan, meron tayong another 1,400 times yung perpendicular niya from this axis. So, let's say this one is Yan. So, ito yung ating axis of rotation. So, yung ating resultant force is 1,400. So, ano yung magiging perpendicular distance natin? So, malamang yung perpendicular distance natin is y and that is equals to. So, yung 400 natin along dun sa axis na yon. So, wala siyang mapuproduce na moment. So, meron tayong 400 times 0 plus 500 times 0. And then, yung ating 100. So, nakaayon siya. Nakaayon siya doon sa in-assume natin na rotation. So, plus 100 times, kung titignan natin, yung distance natin is, how long is that? Gaano siya kalaya? 2 and this is 8. So, kung 2 ito, tapos, kung 2 ito, tapos 8 ito, malamang mula rito hanggang doon ay 6. So, value natin dito is 6. Yeah. And then we have 600. Yung rotation natin is negative. Negative. Ayan. So, sa 600 tayo, ang distance niyan ay puro sulat na. Gaano siya kalayo? I think this is 8. 600 times 8. Yan. So, makuha natin yung value ng y. So, meron tayo 100 times 6 minus 600 times divided by 1,400. So, mayroon tayong 3. Okay? Okay. So, y is equals to 3. So, yun. Na-allocate na natin yung ating resultant force dun sa ating slab. So, ang layo pala nito is equals to 2.5 and this one is 3.